So today we're going to have a little look at adding fractions, and I'm going to use the numbers for the fractions 5/12 and I'm going to add 2/6 to them. So remember that when we've got fractions that have different denominators, we can't just add them together. Okay, we can't just say 5/12 add 2/6 gives us 7/18. It doesn't work like that. What we've got to do is make sure that these fractions have something in common, that they have what we call a common denominator, so the denominator is the same. It's like saying I've got 1/12 and I've got another 1/12. Altogether I have 2/12. Okay, whereas if I said, okay, I've got 1/12 and I've got 1/6, if I add them together, well I can't, because they're different. That's 6th and that's a 12th. They're not the same denominator. They're not worth the same value. Okay, so I'm going to show you, just using my concrete resources, how we can spot a pattern. If you can't spot a pattern or can't spot something these two denominators have in common, let's have a look at it using the concrete. So I'm going to split my whole into 6 equal parts. And I'm going to see how many 12ths I can fit in those 6 equal parts. So that's my whole. 6/6 is the same as one whole. And my 12/12 is going to be the same as one whole. Okay, let's have a little look. 5, 6, 8 1/12, 9 1/12, 10 1/12, 11 1/12, and 12 1/12. Okay, I can see that 2 1/12 is the same as 1 1/6. Okay, so I need to add 2/6 to my 5/12, or because it's commutative, because it's addition, you can do it either way, I can add my 5/12 to my 2/6, which is what I'm going to do. I can see that I've got 1/6, 2/6, which is worth 4 1/12. Okay, it's worth 4 1/12. And I'm going to add those 5/12 to it. So it's going to be 1 2 3 4 5 up to here. Okay, so I'm just going to remove those because I'm not interested in those. I have my 2/6, which is worth my 4 1/12. Then I'm adding my 1 2 3 4 5 1/12. So I'm going to turn these into 12ths. I'm going to turn these into 12ths so that I've got a common denominator of 12. Okay, I'm going to count how many 12ths I've got. I've got 1/12, 2/12, 3/12, 4/12, 5/12, 6/12, 7/12, 8/12, 9/12. So I've got 9/12. Okay, so what did I actually do there? What did I actually do? Well, what I did was I worked out that 2/6 was the same as 4/12. Okay, so essentially what I'm doing in the abstract form is I'm multiplying my denominator here by 2, and then remember we looked at this last week and we said that if we multiplied our denominator by 2, we also had to multiply our numerator by 2 because we had to keep the value of the fraction the same. And the only reason I've done that is so that I can find a common denominator, which is going to be 12, because I know that 12 is the next multiple of 6 that's also in the 12 times tables. Now, because I've got 12ths, I can add them together, and it also shows that I get 9/12. I've kept the same denominators as the ones in your flashback for today. So you have a go at the 7/12 and the 1/6 in the question that you've got. Okay, lovely. Right, let's have a look at the second question. Second question is, which is smaller? And I'm going to use 1 and 2/6 or 1 and 3. 1 and 3/12. Okay, so which is smaller? Now this is different because we were looking at which was greater last week, so we'll have to remember we're looking for the smaller one. And actually I'm just going to write a little note up here just to remind myself that I'm looking for the smaller value. Okay, is there anything you think we can do first of all just to try and see which of these has a smaller value? Can you spot anything? Okay, well, because they both have 1 and a bit, I'm not interested in the 1 for now, because that's the same value. I'm just interested in the bit, the part that they also both have. So 2/6. Let's have a look. 2/6. Remember, I'm going back to my whole, which is 6/6. And because I'm using the same denominator, 6 and 12, I know already that 2 1/12 is the same as 1/6. So, easy done if I compare them. If I've got 2 1/6, pop them like that, and I've got 3/12, I can see that my 2/6 is greater than my 3/12. And again, if I compared them and I found a common denominator so I could compare them, which would I be changing? Would I be changing my 12ths into 6ths or my 6ths into 12ths? Well, can I change my 12ths into 6ths? I can't, because it would be 1/6 and a bit, wouldn't it? But I can change my 6ths into 12ths, and I can do that by using the denominator of 12. So multiply my denominator here by 2, and again my numerator by 2. So that's going to give me 4/12. So it's an equivalent fraction for 2/6. So I can say quite clearly 3/12 is less than my 4/12. So if I look back at my original numbers, I know that 1 and 2/6 is greater than 1 and 3/12. So my 1 and 3/12 is the smaller fraction. That's my smaller fraction. Okay, lovely. Right, let's have a little look. Next question. How many eighths is the same as 3/4? How many eighths is the same as 3/4? You've got how many twelfths is the same as 2/3, but I'm changing the fractions. How many eighths is the same as 3/4? Okay, so I'm going to draw this one out. I've got my whole, okay? I'm going to split it into 4 equal parts, because that's my denominator, 4 equal parts. So I'm going to halve it. It's always easier to halve it and halve it again, I find, if you can. Lovely, I'm going to halve it and halve it again. So each of those is a quarter. Okay, so I've got 1 1/4, 2 1/4, 3 1/4, and 4 quarters. That's my whole. Now I'm looking to see how many eighths is the same as my 3/4. So I'm interested in this part here. Okay? I'm going to compare it with my whole. Now I know that eighths, I've got to split my whole into 8 equal parts. So I'm going to do the same. I'm going to halve it again. And then I've got 4 equal parts. There we go. And I'm going to halve those each again. So I have 8 equal parts. So I have 1/8, 2/8, 3/8. This is all together, obviously. Each of these is just worth 1/8. 4/8, 5/8, and I can stop here at 6/8 because that is my comparison line there. How many eighths is the same as 3/4? 6 1/8 is the same as 3/4. 6 1/8. If you didn't want to do it this way and you're quite happy with fractions like that, you could have looked at 3/4 and thought, right, I'm going to turn those into eighths. I know to do that. I can multiply my numerator by 2, which is going to give me 8, and I can then multiply my denominator by 2, which is going to give me 8, then multiply my numerator by 2, which is going to give me 6. 6/8. Lovely. Okay, let's have a look at this next one. Ooh, Roman numerals. We haven't done these in a while, have we? Okay, so you've got CXL. I'm going to go for MXL. Now, it would be useful for you to find out what each of the Roman numerals were again. If you've forgotten, write them all out. For this, we've got to remember that each letter represents a different value, but some letters together represent another number as well. So for this one, I'm just going to remind you that if you've got the number that is smaller, so if you've got your X before your L, that actually means 10 before 50. Okay, so it means 10 before 50. So if you've got an M, we know that that's 1,000. So you could write it out like this if you like to begin with, 1,000, and then we know that this value here is what we need to be looking at next. So we've got 1,000 and then we've got the X before L, so we've got 10 before 50, we've got 1,040, so we have the value that looks like that. Remember, if it was afterwards, so if you had MLX, that's 10 after 50. So that there would be 1,000 add 60, which would be 1,060. Okay, right, I hope that helps.